hours and we gotta pick it up.
Okay,
But the thing is, if he's not trying to scam you, it's already like
yeah.
hard.
All right. So here's the thing. This is one of those problems where you construct a named point and then you use none of the properties of the named point. So those are my favorite.
Do you use the name point?
You don't use any properties. You just
You
use
use the name point.
Yeah, you use Sharky Devil. Okay. So okay, that's probably spoiled, but they don't know what it is, so it's fine. So
They don't know.
so you basically have some triangle, right? Plonk. This is, I think it's best if we do C at the top. Yeah, whatever. So this is C, A, and B. So we have M and N are the midpoints of arc BAC and CBA. So when we say like BAC, we mean like the arc that goes through B, A, and C. Wait. Well, I thought I needed to sneeze. Okay, yeah. Okay, so mid arc of BAC, that's M. Mid arc of what is it? CBA, that is N. So that's around here. So so M so MN mid arcs including like what should I call it? We'll call it major. We'll just call it the major mid arcs. Well, the mid arcs of the major arcs, right? And then we have our points P and Q, where P is the mid arc of P is the mid arc of BC, Q is the mid arc of AC. So basically, the circle omega 1 is tangent to side BC at A1 and tangent to the extension of the sides AC and BC. So we construct, so what omega 1 is, it's just the AX circle. So we'll just draw that in. Blunk, blunk. We'll make this white.
Oh my god, that is good.
So the only important thing is we only consider A1 here. And we similarly we construct omega 2, which is the BX circle, and it's tangent to AC at. Okay, this is going to be annoying to draw. Never mind. It's going to be tangent to BC at B2. I mean B1. Let's move A1 over here. So another property we have is that it turns out that A1 belongs to segment NP. Right, we'll get rid of that. So A1 belongs to segment NP. So like this is a line. So just imagine that. So you have to prove that B1 also belongs to segment NQ. So like that's also collinear, you know?
Also, if one's collinear, the other.
Yeah.
Like if and only.
Yeah, if and only if. So like the first thing I thought of, right? So okay, let's just not consider the other stuff, right? Let's just consider like let's center it at A. We'll have our triangle ABC, right? Lump. So we'll just have this oriented normally. Forget about this omega. Forget about this B1. We don't want to consider it now. We just want to simplify the problem. We want to figure out
what?
We don't want to just like don't think about omega 2, don't think about B1 right now. We'll just think about NA1P are collinear. What happens because of that? So we'll construct which one? We'll construct P, which is the mid arc of BC. So we'll keep it the same color. So we'll consider this point P, and then we'll consider the mid. Okay, and then we'll have our point N here, which is the mid-arc of CVA. As you can obviously see, that's the mid-arc of CVA.
Are you trying to
No, it's just like like wait, how do you make this good? If you want it more accurate, you make angle C bigger. So if it's like this, right? ABC. Then our mid-arc. Then our mid-arc here. Okay, wrong point. So our mid-arc of what is it? CBA. It's around here, right? So like we'll have our N here, and then our A1 is here. Probably make this. Well, just make this line, and then make this A1, right? So, we'll draw an M. Might as well. M for might as well. So, okay, so the first thing to note is that, like, with our thing, we get that QPMN is a rectangle.
Oh, what?
Because these are both diameters, because they're mid-arcs of opposite. Like, for example, M is a mid-arc of BAC. Yeah, it's mid-arc of BAC, and P is the mid-arc of BC. So they're diametrically opposite. Similarly, N and Q are diametrically opposite. So we'll just draw in our Q here. Look, safely. Just safely nested in there. So we consider, like, note that this A1, it's kind of weird. I don't really like that AX circle touch point. So, but what is nicer to deal with is the in-circle touch point, right? And one thing we know about the in-circle touch point and the AX circle touch point is if we call this point D here, right? And that point's A1, we know that BA1 equals DC, right? So that basically motivated me. And then, okay, do you know what Sharky double point is? Okay, so basically, there's a special point called Sharky double point, and it's like the mid-arc of BC, not containing A, and the in-circle touch point of BC. They intersect the circle again at the Sharky double point, and that is a special point. That's the only thing you need to know about it. There's actually nothing else you need to know about it. So
KG intersects the circle with Sharky double.
yeah, so, like for this question, right? So I was thinking, like, what happens if we reflect N over PM, right? That would still be on the circle, right? So we'll call this image N prime.
What do you say? So ED intersects what? Sharply double point?
The circumcircle at the Sharky double point. That's just like a lemma. Anyways.
What's the definition? What was that?
No, that's not a definition. That's something you get out of it. But you don't even know anything about Sharky double point. That was just something I noticed. I was like, oh, you can construct this Sharky double point, which is a special point, so it might be useful.
So you don't
the
even
word
use
Sharply double makes it sound like technical, but is it some word some high school kids made up? Okay.
No. Anyways,
Yeah,
anyways, so we reflect N over MP to N prime. We note that where it's going to intersect the line BC, since MP does perpendicularly bisect BC, it will intersect it at D because these two have to be equal.
So it's a Sharky double.
So yeah, it will be the A Sharky double point. So what else can we say? But we also got the condition that N, Q are diametrically opposite. What can we say about N prime, and Q, right? So
They're
no. So if we consider this, note that this is perpendicular, right? Maybe a different color. I think black. So we know that N prime is perpendicular to N MP, but N prime is perpendicular to N prime Q as well, because NQ is a diameter.
Yeah.
So that means that MP is parallel to NQ. Right? Do you understand that?
So wait, N. Oh, just because N. Oh, because
Yeah.
NQ's like tells us there. Yeah. Okay.
Yeah, wait, I might keep that in. I should probably keep that in. So we
So
know
you get N prime is perpendicular to N prime.
what?
P, yeah.
Yeah. So,
So
well, it's
N-
parallel to MP.
Yeah.
But we know that MP is perpendicular to BC, right? So we know that N prime Q is perpendicular to BC. So I should probably write this down. Yeah. So, probably this. So we find that N prime, this is perpendicular to N prime Q. N prime is perpendicular to MP. So we get that MP is parallel to N prime Q. And we also note that MP is perpendicular to BC. If we construct the incenter I, we note that ID is perpendicular to BC. So we get that MP is parallel to ID, and then thus we get that ID is parallel to N prime Q.
Yeah.
So what does this mean? We know that since this is the midarc, right? Since Q is the midarc of AC, we get that BIQ is collinear, right?
Oh yeah.
Yeah. So we'll just draw in that line. We'll do it here, right? And we note that like N prime DP are collinear, right?
Yeah.
So, and we know that NQ is parallel to ID.
Yeah.
So we can just, okay, this is reams, but we can also angle chase. So we find, okay, so we can angle chase that B, so B, I, D, P is concyclic.
Yeah.
So how would we do this? It's because ID is parallel to NQ.
Yeah.
So this angle is equal to this angle. But we also know that since BP n prime Q prime is also concyclic, we find that Pn prime Q is equal to PBI. So you get that this angle here is equal to this angle here. And thus it is concyclic.
Where are you gonna write that down? So
Yeah.
it's sometimes hard to know what you're doing. Like you're trying to prove that
Yeah.
BIDP is cyclic, yeah?
Yeah. So okay, so it's
Have you ever heard of someone use the word Reams theorem? Yeah, it's kind of just unnecessary theorem naming. But basically it's saying if you have a cyclic quad, so in this case it's BP n prime q, right? And you have another 2 points which are parallel to one of those pairs of points, then you get another cyclic quad.
Doesn't deserve to have an N.
So I guess the condition is it has to be collinear, right? So BIQ is collinear. And PD n prime is collinear. Yeah. And so the basic idea behind the theorem is like for the 4 points to originally be a cyclic quad, you need the opposite angles to add up to 180, right? But the parallel thing transports that angle closer, so it still adds up to 1.
okay. Yeah, so that's how you prove it with angle chase. I say you can reams this, but I always angle chase. I don't like citing reams. So it's just an angle chase. You get that these IDN and PBI are equal angles. And since the external angle is equal to the opposite angle, you get that's concyclic. So we note that BDI is 90 degrees, right?
D what?
BDI is 90 degrees.
Yeah.
So we get that BPI is 90 degrees, or
Yeah.
BPA is 90 degrees.
Yeah.
So BCA is 90 degrees. So basically what we got is so we basically got that this condition is equivalent to the angle C is 90 degrees. Oh, I should probably write that, yeah. My god, I have to.
Oh yeah.
Yeah. Yeah. So what we get.
Does everyone know why it's 90 degrees?
Yeah.
So it's
Like double bow tie.
Yeah.
Right, so the first claim was once the angle of P is 90 degrees, the angle of C is equal to that. So it's 90
Yeah.
degrees, right? And why was the angle of P 90 degrees?
Because
Wait,
BP.
someone else explain it.
Okay.
BIDP is cyclic.
P.
So you like bow tie BDI. So BDI is 90 degrees, but then that BPI is 90 degrees. But then BIA is collinear because P is the midarc.
Yeah.
So then you just bow tie BPA equaling 90 degrees to BCA.
Does everyone know what he's talking about?
Yeah.
So
Actually, G.
So we're using the fact that BIDP is cyclic,
Yeah.
to show that the angle at P is 90 degrees. So
Yeah.
BPI.
Yeah.
Okay. And the reason that's true is because the angle at D is 90 degrees, right? Because the
Yeah.
tangent is BC and the radius is ID.
Yeah.
I feel like I'm just slower than you. Just slowing the class.
Yeah. Okay. So we basically get an equivalent condition, which is angle C is 90 degrees. So you can just like basically work backwards and like do all of this, but work backwards to get that like B1 also lies on MQ.
Wait, when you did this, was that when you like screamed at the back?
No, that was question 5. Yeah. So yeah. So the full proof, you do all of this, but backwards. And then you get that V1 lies on MQ. But like, I'll say it now, I feel like that's just unnecessary because it's just like, it's all of this but backwards. So
Saying the other thing is also equivalent to
because it's symmetric. It's like since you get it's equivalent, like it's an equivalent condition, the angle C is 90 degrees. The other thing just also works because
So I think that's one of the trademarks of the tournament town. They come up with this really nice problem. Kind of like it's kind of nicer than normal.
Yeah.
You know what would have been nicer though? Using Sharky Devil properties. Oh, that hurt. You know, angle AN prime I is 90 degrees, and we didn't use that ever.
Ethan, does this make sense?
That's actually so smart. It makes me want to become good at geo.
Alright, so if you guys are like, if someone's like kind of low key, like not wanting to admit it doesn't make sense, it's actually recorded, so you can kind of watch it again at some point.
Oh wait, so I understood it all, but then wait, what are we actually trying to prove?
That like basically that if A1 lies on NP, then B1 lies on MQ.
Wait, so did you prove it was if and only if it's 90 degrees? So its argument is working.
If and only if, we can do the if and only if actually. So okay, like
Is that what you're saying?
What?
I'm not saying I'm not trying to be like.
Yeah, no, all of these are if and only if. Like, well.
So the proof goes like if the thing's collinear, like if N1 lies on.
Yeah.
What was it? If A1 lies
on NP, then that if and only if the reflection. Yeah.
And then B1 lies on.
Yeah, if and only if C is 90 degrees.
Wait, B1 is the touch point MQ, right, with the X center?
Yeah, it's the Excircle. It's like
Excircles.
yeah. So how this is like the A version. Like like
Wait, it's the X circle of B, right?
yeah, B X circle, yeah.
Yeah, okay, so it's just the same thing.
Yeah, it's just the same thing, just instead of A it's B, basically. So if you prove it's equivalent, then you get that since like yeah.
Yeah. You do it like the exact same thing.
Yeah.
Like from that side.
Yeah.
But what happened to Ethan?
Yeah. So are we happy with how this works, or
Very nice.
Any questions?
any questions?
Like we asked some questions.
That was very nice.
Okay. Okay.
What motivated to motivated to I get the motivation to point D is like DC
Yeah.
equals BA1, but like why did you then do the Sharpie Devil? Just because like
Because
you know
it's a named point and it has a lot of properties, and I'm like,
so you're expecting to use one.
yeah, I was expecting to use some properties, but then it's like, oh wait, no, I just don't.
He's over prepared.
Because like
What's like the main property of Sharpie? Like
we define the Sharky Devil as the circle diameter AI intersects the circumcircle again, and then we note that like some of the properties. There's like some properties, like for example, PD passes through a Sharky Devil point is one of them. It's like the center of spiral symmetry sending. What was it? I think it's
and
like
we said like AN prime I is 90 degrees.
what? Yeah, AN prime I is 90 degrees. That's because it lies in the circle diameter AI. Yeah. So it's center of some spiral symmetry because it's intersections with circles. You get that from inversion. You can get that like if you label the other two touch points, it's like the foot from D to line EF. If you consider the other touch points E and F,
Yeah.
that passes through a line I and prime. That's proved by inversion.
It passes.
Yeah.
What do you mean passes through a line?
The point lies on line, a line, the line N prime I, where N prime is the Sharky Devil point.
Oh,
Yeah. Yeah. Oh yeah. Another one, N prime DP. That's another property of Sharky double point. You prove that with inversion again. In circle inversion. Oh, dude. None of that was used. It was just. But nevertheless, it's even if you didn't know. Okay. Yeah, close the door. Yes, it's fine. Oh, okay. Okay, but like another yeah. Oh. Okay.
It'll be good running.
I think we should all give him a consolation hug.
Yeah. Okay. But like even still, like I think generally it's a lot easier to work with Incircle than it is to work with Excircle. So even if you didn't know Sharky Devil, even if you didn't know anything about it, this would still be motivated. The reflection would still be motivated.
Yeah.
Because you want to work with Incircle. Yeah.
But I guess like after you draw point D, like that's motivated, but then like what to do with it?
What to do with it? The reflection just seems obvious to me because like PM.
Yeah.
And then you get some like property with Q if you reflect it, and that's nice.
I feel like doing the D thing is not obvious.
What?
Yeah. It might not even be the other thing will solve this.
Bro, I don't think anyone solved this.
That's inspired stuff is actually hard to come up.
Yeah, but it's inspired to like
But
points.
you like 7 hours of Geo.
Oh, I love Geo.
Jaden said he solved like every question except 6.
Oh, exactly. No one solved it. Okay, actually,
Imagine if Jaden learned how to come. Then it was just like there'd be no issue.
Okay. Actually, one struggle I had with the question, I stopped the labeling of B and C, so I got like angle B was 9 degrees for the longest time. I'm like, no, but this is not how it works. And then I realized I did it on GeoGebra. I'm like, bro, I was showing Daniel, dude, it does not. I realized, oh wait, I did the wrong angle. That's my bad. So and then after that, I'm like, oh, it's just angle C, and then okay. Yeah.
No, it's like, oh no, I solved my own problem.
Question complex fashion.
Oh, very nice.
Like 4 minutes house.
Yeah. Was it in the book?
It was like, yeah, it's your green book.
Okay.
Are we all happy with how
Look
this
at
turned out?
I'm not
compare
happy
your solution.
What are you not happy about?
Yeah, like exact same.
because I couldn't do
That's
this.
my one.
Alright, do we end the recording? Yeah. Do we end the recording here?
Huh?
It,
Do we end the recording?
Yeah, is anyone have any questions? Where's Ethan?
you know the JA4?